All right, this is going to be the last video for Note 72, and it is on domain, range, and zeros. We're going to do problem 7 and all the parts of problem number 8. So problem number 7 here, I am asking you for the domain, the range, and the zero. So I'm going to list them out. Right, you can do D for domain. I'm fine with that. You can do R for range. Totally cool. And I am perfectly content with Z for zeros. Please do not, though, just list out points or list out values and assume that I will make up and, figure out which one's which. You need to tell me which one's which. All right, so for my domain, I'm already going to make my little set notation here. And what I'm going to be looking for are my X values. So I have 4 X values. I am going to put them in numeric order. So -4, then -2, 5, and 9. So there's my domain. All done. I'm going to lose all that stuff, and I'm going to redo this, but now I'm going to look for range. And range are my Y values. So I have 4, 5, 0, and 12. And yes, again, I'm going to put those in numeric order. So 0, 4, 5, 12. Little set notation, which does include those braces. All right. And then the last one is my 0. And my 0 is whatever X value makes the function equal to 0. So that's where, nope, that's not a 0. Okay, so it's not 9. That's not a 0, so it's not -2, but that is a 0. So one of my zeros is going to be the X value of 5. And then there's no 0 here, so my zeros technically will be singular. So 0 is, hold on a second. There we go. There's the number 5. All right, so there is my domain, range, and zeros given that set of points. All right, now for question number 8, I'm asking you to find the domain and zeros given various information. So for question number 8, part A, when we're talking about domain, all right, I'll make a little note off to the side here for domain. I want to look for any fractions. I don't have any fractions in part A. I want to look for any square roots. I don't have any square roots in part A. So my domain is going to be -infinity to infinity. All numbers are fine. All real numbers are fine as far as my X goes. I also want to find my zeros. So to find the zeros, those are your X values that make your function equal to 0. So I'm going to take the function, and I am going to purposely set it equal to 0. And I'm going to factor, right? I'm looking for a GCF here. They both have X in common. So X plus 2 equals 0. Awesome. So I've got it factored. Take each factor, set it equal to 0. So one of my zeros is going to be 0, right? X equals 0. There's nothing else to do there. The other factor, X plus 2 equals 0. Go ahead and subtract 2 from both sides, and you're going to get X equals -2. So your zeros are -2 and 0. And those are the final answers for part A, right? We found the domain, we found the zeros, and that is it. Nothing else to do with that one. All right, I'm going to slide over to part B. Okay, still want to find domain, still want to find zeros. So I'm going to make D for domain because I'm super creative like that. So for my domain here, I want to look for fractions. And yes, in part B, I clearly have a fraction. So the problem with fractions is we cannot let the denominator equal 0, right? Denominators are equal to 0. When that happens, you get some number, right? Just whatever this number is divided by 0 is undefined. And mathematicians, we don't like graphing points that are, 0, undefined. It doesn't go well. So to find out what values make my denominator equal to 0, I'm actually going to purposely set the denominator equal to 0 and figure out that 6 is my problem number. So when X is equal to 6, this denominator becomes 0. That's a problem for me. So as far as my domain goes, if I look back to what I did in part A, right, all these numbers were fine. Almost all of those numbers are going to be fine here, except for the number 6. So I'm going to do this as -infinity to 6, and then 6 to infinity. And so the idea is, like, all these numbers from -infinity to infinity are good, but having the parentheses here at the 6's, right, and I do have, they're both the same 6, But the parentheses here means that 6 is excluded as a solution. All right, the other part we're going to do is z for zeros. And I'm going to take the whole function. So x plus 9 over x minus 6 set equal to 0. And I'm going to solve this by cross multiplying. So this cross is 0 times x minus 6. And then this cross, and yes, there is a number sitting underneath. There's not 0. The number underneath 0, remember you can always write this as 1. So multiplying by 1 isn't going to change anything. So that's going to get me x plus 9. All right, on the left side, I have 0 times x minus 6. Gotta love multiplying by 0 because it is 0. So then x plus 9, I'm going to subtract 9 from both sides. I get x equals negative 9. So my 0 is negative 9. All right, so this one we had a domain value that we had to throw out. And in this case, we only had one value that made our function 0. So 1, 0 in the problem. All right, I'm going to do a little shrinky dink on this. Actually, I'm just going to do a little slide over. That'll work. Whoops, close enough. All right, last problem here is part C. Okay, I'm going to do a little shrink. I write huge. All right, so slide that over. It gives me a little bit more room on part C. Okay, so part C, I'm going to find my domain. All right, so D for domain. And in this case, I want to think about the fact that, yes, I do, in fact, have a square root. So if I'm dealing with a square root, I need to make sure that any number underneath the square root, okay, any number underneath the square root has to be not negative, all right? So I want to force it to not be negative, which means it's okay to be positive and it's okay to be 0. So I'm going to take 2x minus 4, and I'm going to set this greater than or equal to 0. Greater than 0 is the positive, and of course equal to 0 is exactly what it means. It's equal to 0. So solving this, we're going to have 2x is equal to, I'm going to move that 4 over, it's positive 4. Divide both sides by 2, and I'm going to get x is equal to, oops, hold on, I lied to you. Hold on. Fix the inequality sign. It's not equal to. These are greater than or equal to, greater than or equal to. Sorry about that for any confusion. My apologies. So what I want now is x to be greater than or equal to 2. Now, if you're a visual person, you're like, what does that mean? That means on my number line, I have the number 2, and the values I'm going to be looking for are anything greater than that. And of course, the equal to part means I'm going to grab a bracket there. So for my domain, I'm going to pick up where this shading starts. And folks, the shading starts at 2, and it's going to go towards positive infinity. Any values less than 2, so 1, 0, any of those things, that's going to make this turn negative, and then we're going to have imaginary answers, and I just don't want any of that stuff, so we're not going to do it, okay? So this domain is going to be from 2 to infinity. Infinity always takes the parentheses. This case, because we have the equal to part, your domain does in fact take a, that 2 takes a bracket on the domain. All right, and then for my 0, or zeros plural, I'm going to take the entire function, and I'm going to set it equal to 0. And the entire function is this whole thing, which does in fact include the plus 8. Okay, so I'm going to take the function, so square root of 2x minus 4 plus 8 is going to equal 0. And now I'm going to solve this thing, all right? So I'm going to subtract 8 from both sides. And I have the square root of 2x minus 4 is equal to negative 8. I am going to, right, everything in math has an inverse operation, so square both sides. So left side is going to turn into 2x minus 4. The right side turns into 8 squared is 64. And then I'm going to, I'm going to add 4 to both sides. All right, so 2x is equal to 68. And then I'm going to divide both sides by 2, and I'm going to get x is equal to, what would that be, 34? Okay. Now, this is where it gets to be a little bit weird, okay? And the little bit weird part is everything is great, right? All of my steps here work, but we need to check this answer, okay? And so what we're going to do to check this answer is we're going to go back up to the original, and I want to make sure that what I did here actually does create a 0. All right, so slide on down. So I got myself some space, because if you haven't figured out, I write huge. Okay, so there's 34. 2 times 34 minus 4 plus 8 equals 0. So I just went back to, whoops, hold on, put that back, grab that. Okay, so I went back to this original equation where I set up the equal to 0 part, and instead of x, I just replaced it with 34. So there's my 34. So let's see what we got here. So 2 times 34 is 68. 68 minus 4 is 64. There's an equal to 0 part that keeps coming down. And then, I keep running out of space, my apologies. Square root of 64 is 8. 8 plus 8 is equal to 0. So that means 16 is equal to 0. And no, it is not. That is a false statement. All right. So what this means, and this is going to be kind of weird, but for this particular problem, this is an extraneous solution. This solution does not, in fact, make this equation equal to 0. It looks like it should, right? Our steps here, nothing we did was wrong, but this does not actually work. And because it does not actually work, just eliminate it. And in this case, your zeros would be none. None or NA. There's no place, there's no value that's going to make this function equal to 0. And that happens sometimes. All right. Now, I will tell you what tipped me off originally when I did this problem, and I'm looking at it going, this isn't going to work, is right here, if you look at the work written in green. And what I have is a square root equal to a negative number. And unfortunately, square roots do not equal negatives. So when we squared this and we created the positive, that's what caused this to create this weird situation of having an extraneous solution. But you can check it if you're unsure. You only have to check it for root problems or square root problems. All right, a little bit of some weird stuff at the end there, but this is domain, range, and zeros. And that's the last video for Notes 72. As always, please let me know if you have any questions or concerns, and I will see you in the next one.